Welcome, dear viewers. Have you ever imagined an object so dense that a single spoonful of it would weigh 1 billion tons? That's not science fiction. It's a mind-bending reality. It exists out there, in the deepest, most mysterious corners of our cosmos. Today, we're diving headfirst into one of the strangest, most extreme objects in the universe, neutron stars. They are smaller than most cities, yet their weight, their gravity, and their magnetic power defy all logic. If you're curious about the weirdest corners of the universe, you're in the absolute right place. Before we embark on this incredible journey, hit that subscribe button and ring the bell. That way, you'll never miss another awe-inspiring trip through space with us. Let's get into it. Neutron stars are born from unimaginable destruction. When a massive star, far larger than our Sun, runs out of fuel, it explodes in a spectacular event called a supernova. What's left behind is a tiny, incredibly dense core. That tiny, super dense core is your neutron star. To give you some perspective, our Sun is about 1.4 million kilometers wide. A neutron star, roughly 20 kilometers across, smaller than a typical city. Yet, this tiny cosmic marvel contains more mass than our entire Sun. How is that even remotely possible? The supernova explosion squeezes the star's core with such immense force that protons and electrons merge into neutrons. The result is a sphere of pure neutron matter. It's so compact that a sugar cube of it would outweigh Mount Everest. Scientists describe this as one of the most exotic states of matter in the entire universe. It's not solid, liquid, or gas. It's something else entirely, a true cosmic enigma. Let's rewind a bit to understand their dramatic birth. Stars, at their very core, are colossal nuclear fusion machines. They begin by fusing hydrogen into helium, releasing enormous amounts of energy in the process. That energy pushes outward, perfectly balancing the inward pull of gravity, keeping the star stable. But over billions of years, the star's fuel inevitably runs out. Hydrogen becomes helium, then helium becomes carbon, then neon, and so on. Eventually, the fusion process creates iron. And that's the endgame for a star. Iron doesn't release energy when it fuses. It actually consumes it. So the star suddenly loses its delicate balance. Gravity takes over with overwhelming force. The core collapses in a mere fraction of a second, triggering a violent, eventually, the fusion process creates iron. And that's the endgame for a star. Iron doesn't release energy when it fuses. It actually consumes it. So the star suddenly loses its delicate balance. In stars that are between 4 to 8 times more massive than our Sun, this collapse doesn't create a black hole. Instead, it creates a neutron star. It's like a cosmic tombstone, incredibly dense, often cold, and pulsing with an almost unbelievable magnetic fury. These objects are truly the universe's ultimate survivors. The story of how we discovered neutron stars is just as fascinating as the stars themselves. In 1967, a brilliant young astronomer named Jocelyn Bell Burnell was scanning the skies using a radio telescope. She picked up a series of incredibly fast, repeating radio signals. They were so regular, so precise, that they seemed almost artificial. At first, her team even thought it might be a message from aliens. They jokingly labeled it LGM-1 for Little Green Men. But the truth, as it turned out, was even more mind-blowing. She had stumbled upon the very first pulsar, a type of neutron star that emits powerful beams of radiation, much like a cosmic lighthouse. Every time that powerful beam swept past Earth, we received a signal. It was an incredible breakthrough. Since then, we've cataloged thousands of neutron stars, each one more extreme and awe-inspiring than the last. Not all neutron stars are created equal. In fact, scientists have identified at least 9 distinct types, each with its own unique and bizarre quirks. Here are some of the most fascinating ones. These are rapidly spinning neutron stars that shoot out radio waves from their magnetic poles. If Earth happens to align with one of those powerful beams, we detect regular pulses, like a rhythmic heartbeat from deep space. These neutron stars are incredibly unstable. Their emissions come in sudden, violent bursts, sometimes quiet, sometimes explosively loud. The first major burst was recorded in 1979, completely baffling astronomers who had never seen anything like it. These rotate more slowly, taking between 2 to 12 seconds per spin. Still, that's incredibly fast compared to Earth's 24-hour rotation. Some, however, spin much faster, over 700 times per second. Think of these as recycled neutron stars. After absorbing material from a nearby star or debris from a supernova, they gain immense speed and start spinning incredibly fast. The fastest ever recorded spins once every 1.55 milliseconds. That's over 38,000 revolutions per minute. These are the true monsters of the neutron star family. Their magnetic fields are 1,000 trillion times stronger than Earth's. If a magnetar were as close to us as the moon, it could wipe credit cards clean and scramble satellites across the globe. They burn incredibly bright but fast, usually dying within 10,000 years. Each of these types offers a different window into the extreme physics of the universe. They help scientists test theories about matter, gravity, and the very fabric of space-time itself. Now, here's a truly mind-bending scenario. What if two neutron stars crashed into each other? This isn't just a hypothetical question. It actually happens, and it's one of the most powerful, awe-inspiring events in the entire universe. When they merge, one of two incredible things can happen. They either form an even larger, more massive neutron star, or they collapse completely into a black hole. But there's even more to it. The collision sends out gravitational waves, ripples in space-time, first predicted by Albert Einstein. In 2017, scientists detected such a ripple from a neutron star merger for the very first time. It confirmed decades of theory and opened a brand new era in astronomy. The impact also creates gold, literally. Heavy elements like gold, platinum, and uranium are forged in these cosmic crashes. So, the jewelry you wear, it may have come from the death spiral of two ancient neutron stars. How cool is that? Neutron stars challenge everything we think we know about physics. They're small but unbelievably powerful, invisible to the naked eye, yet absolutely crucial to our understanding of the universe. They spin, they pulse, they explode. And they teach us that even in death, a star can leave behind something truly extraordinary. These cosmic marvels continue to push the boundaries of our scientific understanding. So, did you find the topic of neutron stars interesting? Let us know in the comments below. If you made it this far, you're truly awesome. Smash that like button, share this video with a fellow space geek, and don't forget to subscribe for more deep dives into the unknown. Until next time, stay curious.